Hello everybody, Steiner here. Welcome to Controversy Central, where we take on controversies that really matter. Now here, in the teachings of the modern-day Flat Earth movement, controversy seems to be the name of the game. Its teachings gained momentum when certain people flooded social media with the controversial notion that the Earth cannot be a globe. Rather, they said, the Earth is flat. Surprisingly, this movement grew quickly, to where it has even earned some attention in the mainstream media. But alongside its dramatic growth, fractures began to appear within its confines. A growing variety of flat Earth models were being proposed, since nobody could produce a flat Earth model that was an actual, accurate scale model of the Earth. Among the numerous designs that have been proposed, the most popular one so far has been the North Polar Azimuthal Equidistant Map. Nevertheless, every flat Earth design that has been attempted, including that one, has failed miserably for the simple reason that one unavoidable fact continually gets in the way. And what is that fact, you might ask? Well, that fact is the unavoidable reality that the Earth is actually a globe. And if you are having a hard time accepting that as a fact, I've backed up this claim in my previous video, which I called the Blockbuster Flat Earth Takedown. In it, I've provided one piece of evidence after another that shows the Earth to be a globe. And I also used it to specifically debunk the popular azimuthal equidistant model. One well-known flat earther, Adam Carter, would like us to believe that there is hardly any difference between the azimuthal equidistant model that he proposes and the globe model, by suggesting that a soccer ball can be wrapped by a tin foil or paper model of the azimuthal equidistant map to show that once curvature has been applied to the azimuthal equidistant model, there is little to differentiate it from the globe model. I will let him explain this in his own words.
The big question for you to answer is, if the circular map and the globe show the same thing, the only difference is that one of them has a curved surface and the other is flat. People seem to recognise the similarities between them, but for some reason Antarctica seems to puzzle some who can't quite grasp how a deep circular boundary has been condensed into a single landmass. It's almost counterintuitive. The circular maps are not that much different from the globe, except that one of them is flat and the other is spherical.
Strangely enough, earlier in the same video, Carter stated a fact that is completely at odds with what we just heard him say.
Before we go any further, I ask you to consider one thing: the sense of scale that's needed when thinking about the maps of the world. I'll use one familiar layout for a moment, as that's all we need at this stage. If we take any of the circular maps with the North Pole at the middle, the world is essentially a disk with a diameter of about 25,000 miles and given an approximate surface area of about 490,000 square miles. Yes, the surface area is about 2.5 times that of the globe, but the extra is mostly oceans and ice.
This doesn't really seem to make any sense. That is, until we hear him say the following.
The big question for you to answer is, if the circular map and the globe show the same thing, the only difference is that one of them has a curved surface and the other is flat.
Adam Carter actually spends a fair bit of effort downplaying the significance of the fact that the azimuthal equidistant map gives us an Earth that has a surface 2.5 times that of the globe. He needs to do this to make the main point of his Maps Schmaps video sound plausible. The idea that there really is very little difference between a circular map with the North Pole in the center and the globe. I intend to confirm in this video what I've already shown in my previous video, that this difference is extremely significant. I can think of no better way to show how significant these differences are than to follow Adam Carter's instructions for an experiment that he says helped convince him that the azimuthal equidistant map is the real map of the world. To do that, we will take a look at what happens when we have tin foil and paper models of the flat Earth and wrap them separately around a mini-sized basketball. I will do the wrapping in 3 different ways for 3 very different effects. I will also play Carter's instructions as I proceed with the experiment that he had suggested in his video, Flat Earth SMARTS 6 Maps Schmaps. Doing this will make it easy for everyone to see that I am being careful to follow them step by step, with what little information he provides. It would have been much better had we been able to watch him demonstrate how he did it. So I contacted him in the comment section of one of his later videos to ask him where I could find a recording of his actual experiment. That's when he sent me to this video, which seemed to me to provide nothing more than CGI images that he used for the purposes of illustration. So I questioned him further. I will put that conversation from his comment section on the screen and read it so that we all can know what his response was. As you can see, he goes by AJC 1844. I posted in this comments thread since it spoke to the same topic as my questions. So I asked, please direct me to the video in which you mapped the soccer ball. So far, I have only seen the video where you talked about having done so. AJC responded, Flat Earth Smart 6, Maps Schmaps. So I said, AJC, thanks. Pardon me for seeming to be a little confused here, but I have already seen that video. In it, you talked about having done that experiment a long time ago. So I thought the images you were showing us of the tinfoil on the ball were CGI, not actual photographs. Was I mistaken? If not, do you have any actual photographs? He answered, yes, you were mistaken. The purpose of the video was to show people something they could do for themselves. My response to that was, AJC, thanks again. So that's how I can expect my end result to look when I'm finished doing your experiment? Did you need to cut off a lot of tinfoil to make it look like that? If so, how much? His answer was, I didn't cut off any. Let's not forget the original line of thought. It was to give people an idea about how a circular border will become a single landmass if the map is wrapped around a ball. After which I said, AJC, okay, thanks. And that was the end of the conversation. So now let's see whether or not I can wrap the ball in such a way as to produce an end product looking anywhere near as elegant and perfect as the one in Adam Carter's video. We'll start by listening to the beginning of his instructions.
It's almost counterintuitive, so I propose an exercise that I did when I first came to Flat Earth. You can try this for yourself. I used a sheet of tinfoil as it holds its shape, but you can do this with a sheet of paper just as easily.
So I got some tinfoil and taped together 2 1-foot wide strips. Then I used a 22-inch diameter hula hoop for tracing out the flat Earth model to cover the ball. I also had a 22-inch diameter Gleason's map printed out. These I then cut to size. From these I made 2 flat Earth models out of tinfoil and 1 flat Earth model using a Gleason's map printed on paper with clear packing tape on the back for added strength. What took me quite a while to do, I am showing here in as short a time span as I thought was necessary to give you an idea of the process I went through to produce these models. Now we'll listen to more of Carter's instructions.
Get yourself a small football. One of those 7-inch balls is perfect, and to measure the circumference. It'll be a little over 21 inches. Now get your sheet of tinfoil and cut out a circle whose diameter matches the circumference of the ball, in this case about 21 inches. Get yourself a marker pen and draw the circular map with Antarctica onto the tinfoil circle. There are no points for artistic merit, but try to keep the land masses proportional. Include the equator and have Antarctica running around the edge.
Since I didn't have a soccer ball of the size AJC recommended, I went shopping and found a ball at a dollar store that was close to the exact size of Carter's mini soccer ball. The only real difference was that this one was a mini basketball. So that's what I used as my globe model. I made sure to draw in both the equator and a line to approximate Antarctica on each of the two tinfoil models. Because I'm not an artist by any means, and didn't want to make a mess of the tinfoil I'd worked so hard to form into two flat Earth models, and because I didn't think it was necessary to do so anyways, I decided to not attempt drawing in the rest of the continents. I then tested the models to make sure that they would wrap over the ball enough to reach from the arbitrary North Pole location to the arbitrary South Pole location on the ball. Now let's hear what Carter says to do next.
Once you've drawn your map out, wrap it around a ball, and hey presto, you have your globe. You'll see that you really only need to scrunch up the southern hemisphere to turn a flat, circular map into a globe, and Antarctica comes together nicely as a single landmass at the bottom. The circular maps are not that much different from the globe, except that one of them is flat and the other is spherical. If you are honest with your layout, you'll see that the equator still runs around the centre of the sphere, and that most of the northern hemisphere matches any other globe. The only real difference is in the southern hemisphere, where the land masses will have been reduced a little bit, but since most of the southern hemisphere is made up of oceans, nobody could really tell the difference in real life.
Before I start wrapping the ball, I am putting some double-sided tape on it to help keep the tinfoil in place during the wrapping process. I'm trying, not very successfully, to create a smooth tinfoil surface with straight lines converging at the South Pole, as we saw illustrated in AJC's model. In fact, I'm having a lot of trouble trying to make it look anywhere near as smooth as Adam Carter's picture shows. As I am wrapping the ball, I am finding that the tinfoil does a pretty good job of scrunching up just like AJC said it would. Now, as I am wrapping the southern hemisphere, I am taking short stretches of the tinfoil at a time, pinching each stretch in such a way as to create a short flap, which I then fold flat against the ball. I sure hope, AJC, that you will post a video showing exactly how that was accomplished. It just may be that I am extraordinarily poor at this type of thing. But this sort of discrepancy could lead some to conclude that your picture was indeed CGI, unless you demonstrate otherwise. Nevertheless, after some scrunching up of the tinfoil, together with some folding of flaps of excess material, I have the tinfoil clinging quite closely to the ball. But this still leaves me with one big unanswered question. How much excess tinfoil would I get if I did as little scrunching up as possible and covered the ball the best I could while cutting off any excess? To answer this question, I will now use the second tinfoil flat Earth model and do the best I can to find out. To help hold the tinfoil in place, I am again using some double-sided tape on the ball. Now the fun begins. Starting from the center of the tinfoil, which represents the North Pole, I am trying to prevent it from scrunching up as much as I can without ripping the fragile foil. It appears to me that I would need to make an infinite number of protruding flaps that I would then need to cut off if I were to be able to create a completely smooth surface. In fact, what we are seeing here in my effort to wrap a spherical surface with another surface that was initially a flat plane can be easily predicted using the readily accessible mathematics that pertains to this physical process. So I've settled on a strategic compromise that will allow me to at least get a rough idea of how much tinfoil will be left over after I've completely covered the ball. That compromise is to create 4 larger flaps, as you see me doing here. I'm using extra strength tinfoil to make it possible to create as tight a skin over the ball as possible while not tearing the foil. This process makes it possible for us to take a good look at the way in which a flat sheet distorts when it is wrapped around a spherical surface. We can see that there is even excess surface north of the equator that needs to be removed for the flat sheet of foil to match the shape of the sphere. We also see that the amount needing to be removed increases slowly as we move south toward the equator. After that, the amount increases dramatically. Another interesting point to note is that no foil needs to be added or removed to maintain the correct north-south coverage. In other words, the north-south distances on the sphere are identical to the north-south distances on the flat circular sheet. As we observe what has just taken place, let me point out something that every flat earther should consider very carefully. The fact of the matter is that we could have consulted those who have specialized in areas such as physics, math, and cartography, and we would have discovered that the very details that we just observed are the same basic results that they would have predicted for this experiment at this stage, based on their knowledge of the science involved. I will also point out that all of what we have observed thus far fully supports the evidence that I have already supplied in my last 3 videos, for which I've provided links below. Now it is time for me to start cutting off all the extra foil. And it does seem that there will be a lot of foil left over from using this flat Earth model to cover this globe model. It'll be interesting to see just how much excess we will be left with. As I'm cutting off the extra foil, I'm also labeling and saving each piece so that I can use them later to see how much of the ball they will cover. I am also doing my best to make clean cuts, but I am finding that my cuts are fairly rough. Though by stretching and taping the foil, they do come together in a good enough way to cover the ball reasonably well at each seam. The excess foil reaches from the South Pole almost to the North Pole, so as you can see, I am taking a fair bit of time to make all the cuts, tape them together, and label all the pieces. One other thing I've been trying very hard to do is to create a smooth surface with the tinfoil. But that appears to be an impossible task. Now that I've cut off all the excess, you can see that I've completely covered the ball with a tinfoil model of the flat Earth. And right here in front of us, it looks like I have a lot more foil left over than AJC's video would have led us to anticipate. Now it's time to remove the tinfoil from the ball so we can start covering it with the leftover pieces. A bit of a chore, but all the tinfoil and tape has now been removed. and I'm now ready to put on the excess foil and see how far we get in our attempt to cover the ball. To help hold the pieces on the ball while I maneuver them and tape them together, I will again stick double-sided tape onto the ball. Now it's time to begin covering the ball with those leftover pieces. I'm again doing my best to tape together the pieces in such a way as to leave no part of the ball uncovered. This will take some time, since it's a bit of a jigsaw puzzle, and I have a dozen cut off pieces to tape in place. And even some of those pieces won't curve very well until after I've created and cut off small flaps of tinfoil. Those smaller pieces are proving to be very useful for filling in unavoidable gaps that appear between some of the larger pieces. So finally, we can see how much of the ball the excess foil was able to cover. I'm sure that anyone who believed AJC when he said that the excess surface representation of the flat Earth model would be insignificant is very surprised to see that the excess has covered the entire globe Earth model a second time, with some still left over. So let's see whether or not this remaining foil can cover this tennis ball. Sure enough, it did. Again, this is in line with what any competent mathematician would have told us from the start, had we asked. In fact, using simple math, we can easily determine exactly how many times the flat Earth tinfoil model could cover the globe if it were applied with no scrunching up. For you who are curious, here are the mathematical formulas, the figures for my models, and the actual amount of times my globe model could be covered by its corresponding flat Earth model based on the math. I can make the flat Earth model whatever size works best. But since Carter used a ball with a 7-inch diameter as his globe model, I decided to start with a similar sized ball, and that's why I got the mini basketball. Since that became my globe model, that also determined the size that the flat Earth model would need to be. So these facts dictate that I must start this exercise with the measurements of the ball. We first need to know its circumference so that we can use that as the diameter of the flat Earth models that will be used for wrapping the ball. Mathematicians have done a wonderful job over the centuries of coming up with formulas for problems like these that would otherwise take an enormous amount of time, along with a solid grasp of the mathematics involved for any one person to figure out. So I will skip all the hard work and just plug the numbers that I have in front of me into the existing formulas to get the correct answers. The circumference formula for a ball is C equals 2 pi r, with C standing for circumference and r standing for radius. Since the ball's diameter is 7 inches, then its radius is half that, which is 3.5 inches. As I will be doing with all other such calculations, I will round off 2 times pi to 2 decimal places. This will give us 6.28, and we have calculated that the radius is 3.5 inches. Therefore, the circumference of my mini basketball is 6.28 times 3.5 inches, which equals 21.98 inches. Since we also need to know the area that the tin foil will be covering, we will need to know the area of the surface of the mini basketball. The formula we need to find that area is A equals 4 times pi r squared. Using the order of operations that mathematicians have also provided for us, we square the radius, 3.5 inches, first to get 12.25 square inches. Next, we multiply pi by 4 to get 12.57. And then we multiply 12.25 square inches by 12.57 to get 153.98 square inches. The next thing we need to know is the size of the flat Earth model that is needed to cover the ball completely. Since my mini basketball is almost the same size as AJC's soccer ball, the diameters of the flat Earth models are also nearly identical. As he said, his was a little over 21 inches, while mine is approximately 22 inches. So to find out the area of the flat Earth map, we simply use the appropriate formula for that and plug in our numbers. Since the formula for the area of a circle is pi r squared, we again do our calculations using the mathematical order of operations. We first square half the 22-inch diameter, which is 11 inches, to get 121 square inches. Then we multiply that by pi to get 380.13 square inches. The final step is to divide the area of the flat Earth model by the area of the globe model to see how many times larger the flat Earth model actually is than the globe model. So we divide 380.13 square inches by 153.98 square inches to get 2.47. This means that, just as AJC admitted in his video, the flat Earth model should be able to cover the ball almost 2.5 times. Now you might be wondering, since the tennis ball is far less than 1/2 the size of the mini basketball, why wasn't there even more foil left over? To know the reason for that is to know the reason why no model of Earth other than an actual globe model can be an accurate scale model of the Earth. As I said earlier, I would have needed to create and remove an infinite number of tiny flaps to prevent the foil from scrunching up on the ball. The reason for that is that as soon as we start to introduce curvature to a flat surface, distortion takes place and portions of the flat surface must be removed to allow for the curvature. Now apparently, to have flat Earth smarts does not mean that a person needs to place any emphasis on such down-to-earth mathematical facts as these when attempting to establish flat Earth realities. In fact, they must be downplayed as much as possible, since they otherwise just tend to get in the way. Had AJC simply accepted the real implications of these facts, he could have saved himself a number of years of wandering in the flat Earth wilderness. And he would never have made such statements as the following.
If the circular map and the globe share the same thing, the only difference is that one of them has a curved surface and the other is flat. The circular maps are not that much different from the globe, except that one of them is flat and the other is spherical.
Now that's what I call missing it by a country mile. Or, to be far more accurate, missing it by hundreds of millions of square miles. Which leads me to a very important question. How can it be that all those hundreds of millions of square miles are completely missing from all the multiplied millions of maps that ordinary people going about their everyday lives use on a regular basis in all parts of the globe for a multitude of purposes, not the least of which is determining property locations, sizes, and boundaries? And this brings me to take a closer look at AJC's claim that the pictures of his tinfoil experiment that he presented in Flat Earth Smart 6 are not CGI. So let's examine the tinfoil that he says he used. Was it this? Or was it this? Or are they both the same, with AJC simply pre-crinkling the foil in anticipation of the need to do so when wrapping the ball? If it was the latter, he did an absolutely amazing job, especially considering the fact that this portion to the left has identical crinkles as this portion to the right. I remember watching a few flat Earth videos pointing out the fact that such repeating patterns in certain NASA images of the Earth are indications of CGI production. But let's carry on and take a look at its final product. Take a close look at the symmetrical lines as they converge so cleanly at the South Pole. And how is it that the line for the equator and the coastline of Antarctica end up being so crisp and clear? And now take a look at his tinfoil model side by side with the one of mine that I created following his instructions. If his doesn't look like CGI, I don't know what does. Anyone caring to voice your opinion one way or the other, please do so in the comment section below. I'd be very interested in hearing your thoughts on this matter. And just as a reminder, this was AJC's response when I asked him whether I was right or not in assuming that the pictures in his video were CGI. I thought the images you were showing us of the tinfoil on the ball were CGI, not actual photographs. Was I mistaken? If not, do you have any actual photographs? He answered, yes, you were mistaken. The purpose of the video was to show people something they could do for themselves. My response to that was, AJC, thanks again. So that's how I can expect my end result to look when I'm finished doing your experiment? Did you need to cut off a lot of tinfoil to make it look like that? If so, how much? His answer was, I didn't cut off any. Let's not forget the original line of thought. It was to give people an idea about how a circular border will become a single landmass if the map is wrapped around a ball. So there you have it. I can hardly imagine anything being more carefully designed to deceive than this. Can you? All this evidence leads me to believe that AJC used every trick he could come up with to convince us that the flat Earth model is, to all intents and purposes, the same as the globe model, minus, of course, the curvature. But why would he go to all the trouble of doing this? Well, let's see now. He first tried to convince us that there was hardly any practical reason for any of us to bother using maps in today's world. So that would make it so that maps would be mostly unnecessary and therefore irrelevant.
This really only matters for those who would like something on which to build their view of the world. No, you don't need a map.
Now, if you buy into this idea that we don't actually need a map, this would also make it somewhat pointless for you to consider the few obvious differences that did exist between flat Earth maps and the globe. These differences would then not have any actual bearing on real-world situations. Of course, this might not fly very well with the millions of ordinary people that use maps as a necessary aspect of their daily lives, but Carter's slick production could still sway many others into his way of thinking. Since we all know that the globe model works extremely well as the basis for all commonly used maps, the desire to erase as much of the differences between that model and the flat Earth model as possible could very well have been the prime motivator for his endeavor. As a fatal blow to all of Adam Carter's best efforts, the last segment of this video will show, in the most graphic way possible, the impossibility of erasing those differences without drastic effects being the result. Those differences go far beyond merely doing away with some remote and unimportant tracts of ocean. In fact, large chunks of continents will also disappear, together with any parks, farms, and even major cities that happen to be situated on those continental chunks for which there is no longer any room to be found. So let's get started. Using the Gleason's map, I will do as I did with the grapefruit in my last video, only this time I will be using a detailed map instead of a grapefruit. And I will be reversing the process, Instead of transforming something that originates as a globe model into a flat Earth, I am now transforming something that originates as a flat Earth model into a globe. Both processes show the failings of the flat Earth model when attempting to use it as a scale model of the Earth. I will do my best to cover the ball with this paper copy of the Gleason's map. The most logical way to do so that I could come up with was to cut along each of the longitudinal lines on the map, leaving all the strips connected at the North Pole. Having done that, I will now put some double-sided tape on the ball to help hold the paper in place as I wrap it around the ball. To make it possible for each of the strips to touch the ball along at least one of its edges, I am being forced to start overlapping them. As you can see, I have been able to lay the strips of paper fairly nicely near the North Pole. In the process, I'm trying to lay the strips as evenly as possible. It is becoming rather difficult to shape them to follow the contour of the globe. In spite of the fact that I cut the flat Earth model into strips joined at the North Pole, they have no intention of even attempting to lie flat. And I certainly don't intend to cut them into a whole bunch of even narrower strips to try to flatten them out better. The problem I have now run into is the simple fact that I must try to make the entire circumference of the flat Earth model occupy the very same space on the ball that represents the South Pole, which is normally represented by a single tiny dot. A little more math will show us what I am up against. Having the formula circumference equals pi times the diameter, or c equals pi d, and having the diameter of the flat Earth model as 22 inches, we can easily find out how great the problem actually is. Pi d gives us just over 69 inches. This means that what I have here is me doing the best I can to cause a line 69 inches long to occupy the space of one tiny dot. As a result, I am using some tape to keep the paper strips as flat as possible as I try to make them conform to the contour of the ball around the South Polar region. And now that the ball has been wrapped, I will use highlighters to color the entire exposed surface of the flat Earth model. Now I will remove the flat Earth map from the ball so we can see just what portions of the map I was unable to color. I am now spreading the flat Earth map out on a flat surface so we can see the end result. And here it is. What you now see is that more of the surface of the flat Earth map is white than colored. In fact, as earlier calculations have shown, for each square inch that is colored, 1 1/2 square inches is white. So to transform a flat Earth model into a globe model means that all of the white area that we see will have to be discarded. A closer look is even more revealing. The area that I colored green lies between the equator to the south and the 45th parallel to the north. We see significant amounts of white surface in that region. And the area that is a brownish color goes from the North Pole to the 45th parallel in the Northern Hemisphere. Yet, even that far north, we can see white strips showing. This shows us the very same thing that the math makes absolutely clear. On the azimuthal equidistant map, there is only one place that there is not distortion of distance, and that place is the North Pole itself. Everywhere else, compensation must be made for the fact that extra surface area must be removed to allow the flat Earth model to properly transform into a globe model. So no amount of effort can ever make it possible for an azimuthal equidistant map to be a proper scale model of the Earth. As you can see, it is not only enormous portions of the oceans that have disappeared, large sections of land have also gone missing from the surface of the Earth. And with those sections, islands, farmland, mountains, and even some major cities have vanished. South of the equator is where we see the greatest amount of white surface area. Large portions of South America and Africa are now gone. And since a large part of the landmass of Australia is white, that also has been eliminated. Nevertheless, because of the way that the strips of paper have overlapped, it appears that Sydney on the east coast has been preserved. But I can't say the same for Perth on the west coast or Melbourne to the south. Even the island of Tasmania, home to over 500,000 people, and much of New Guinea have been sacrificed in the process of transforming a flat Earth to a globe. This reinforces a point that I made in my last 3 videos. The azimuthal equidistant map introduces tremendous error by adding huge amounts of extra surface to the Earth. Ordinary people are using globe-based maps by the millions every single day in their travels and in many of their other endeavors. Outdoorsmen hike wilderness areas where accurate maps can make the difference between life and death in thousands of locations around the world using such maps. Millions of others travel through unfamiliar territory on back roads and major highways while relying on such maps. We would be hearing of thousands of tragedies if these same people were relying on the highly inaccurate azimuthal equidistant maps like the Gleason's map. As Adam Carter admitted in his video, the Gleason's map has a surface area 2.5 times that of the globe. Travelers would quickly get disoriented and lost with maps that unreliable. As I showed in my last video, even a 43-mile error when Apple Maps first went into production placed people in life-threatening situations. Millions of square miles of difference, as exists in the Gleason's map, would do far worse. And now, think about this for a moment. One thing that Gleason's and many other azimuthal equidistant maps do have going for them is that they use the same basic coordinate system as do most other modern maps. This makes it possible to place every landmark, be that a city or island, at the correct distance from the North Pole, and along its correct meridian of longitude. The only problem is that east-west distances are distorted, and they become more distorted the further south we go. But at each parallel of latitude, the east-west distortion is spread evenly around the 360 degrees of the circular flat Earth map. And as I said earlier, this distortion becomes more pronounced the further south we get. So this system allows us to see a correlation of distance and direction between the Gleason's map and the globe map, with the only significant difference being the unavoidable east-west stretching of the flat Earth map. I am saying this to bring to your attention the fact that discarding the coordinate system in attempts to create a better flat Earth map is absolutely futile. In fact, it's beyond futile. It makes for an even more unworkable map, as Tyler Dan discovered in his botched attempt to create a flat Earth map that would be superior to any map in existence, globe, flat Earth, or otherwise. He abandoned the use of coordinates and placed his airport locations according to a system of triangulation that brought him to the point where he realized that he needed to insert a second Australia to allow for proper positioning of various known airports. Of course, that only made matters worse for him, so in the end, he had to abandon his project altogether. Every other attempt to come up with a flat Earth model while abandoning the proper use of a coordinate system is doomed to suffer a similar fate. Having said all that, my experiments here have shown that no azimuthal equidistant map can properly be used as a scale model of the Earth. I began by following Adam Carter's instructions on how to convert a flat Earth model into a globe model. Then I decided to go beyond just following through on Adam Carter's basic recommendation to use a ball and either tinfoil or paper. In fact, I wrapped a basketball with tinfoil 3 different times for 3 different reasons, and a tennis ball with tinfoil 1 time. Then I wrapped the same basketball with a paper model of the Gleason's map. In doing so, I have shown beyond a doubt that, as far as creating a scale model of the Earth goes, the differences between the azimuthal equidistant map and the globe map are enormous. And, as my previous video, to which I have a link below, shows, only the globe model can accurately portray the distances and directions between all locations that we find on the face of the Earth. Mark Sargent has done a lot to promote Adam Carter's Flat Earth SMARTS video series. I, on the other hand, have demonstrated, by using Carter's own video presentation, documented statements, and instructions, that he has deliberately misrepresented reality in order to deceive. And I have only just begun in my exposés of a variety of deliberate deceptions perpetrated by Flat Earth leaders. If this has been of interest to you, be sure to click on the subscribe button below and then the notification bell. You will not want to miss my next video in which I expose another Flat Earth YouTuber's deceptive tactics. Until then, let me know what you think in the comment section below, and thanks for watching.